So this web work is actually kind of a tricky one, but remember, we're still in the first chapter, we're still doing review, so what we're looking for are patterns. And one of the key patterns that I notice when I look here is in the denominator. Do you see? I have a 1, and then I have a 16 cosine squared of 5x. And that pattern speaks to me, let me get a little deeper, that pattern speaks to me something like if I can in any way, shape, or form turn it into a 1 over 1 plus u squared, then I know that if I integrate that, that gives me an arctan. So my brain says, is there a way for me to somehow go ahead and change that into this pattern using a u-substitution? Well, let's see. Notice if I want to change that first one into 1 over 1 plus u squared, I have to start here by looking for an item to be u. And so if I look on my bottom, I actually have 1 plus and then 16 cosine squared. Both 16 and cosine squared are squares. In fact, if I take 4 times the cosine of 5x and I square that quantity, notice that gives me 16 cosine squared of 5x. And that makes 4 times the cosine of 5x an excellent candidate for u. If I let that be u, well then the bottom becomes 1 plus u squared. Now, in order for a u substitution to work, we also have to find the derivative of u. And so let's see. It looks like it's going to play out well because if u is cosine, the derivative of u is sine, and that's also appearing in my integral. Alrighty, so I don't know if this makes sense, but I've got my pattern now down. I'm going to let u be equal to the 4 times cosine of 5x. And then du, or the derivative of u, is going to be 4 times the derivative of cosine, which is negative sine, times the derivative of 5x, which is 5. Or in other words, dx at the back end. Or in other words, du is just negative 20 sine of 5x dx. Let's put all the pieces into our integral and see where we're at. Let me rewrite our original integral. So we're starting with 4 sine of 5x in the numerator, and in the denominator 1 plus 16 cosine squared 5x. But we said let's change this up a little bit and rewrite our denominator as 1 plus a quantity squared. So we made that 4 times the cosine of 5x quantity squared. Now, I also have that 4 sine 5x, so if you like, I'm actually going to put that on the side. I've got, well, actually, no, I'm going to make it a little too complicated that way. Let's keep it on the top. So we've got 4 sine of 5x dx. Okay, I'm going to color code things. My u is pink, and that's going to be 4 cosine of 5x. So here is 4 cosine of 5x, and so I'm going to replace that with u. Let's also color code du. Du is negative 20 sine 5x dx. I don't have a negative 20 sine 5x. I do have a 4 sine 5x, or specifically, I actually do have a sine 5x dx. So how about we just solve for sine 5x dx, and that means negative 1 over 20 du will be replacing my sine 5x dx, the green part. So negative 1 over 20 du is what I'm going to put in that place. When I put that all together, I still have this 4 on top, so I've got a 4 times a negative 1 over 20 du. And on the bottom, I have a 1 plus u squared. And I think we're so close to being done. Let's simplify that top as 4 over 20, or negative 1/5. So, you know me, I like to pull out those coefficients, or those numbers that are multiplied. So I'm going to pull him right out. leaving me with 1 over 1 plus u squared, which I recognize right away. The antiderivative of 1 over 1 plus u squared was what we were looking for. That's my arctangent. And of course, the last step is to go back and replace that arctangent of u with the arctangent of what u really is, which is 4 cosine of 5x. And so that's going to be our final answer, negative 1/5 arctan of 4 cosine of 5x.